Recall that distance is rate times time. If you solve that for rate, you get d over t. If you solve that for if you solve it for r, you get d over t. If you solve it for time, you get d over r. So these are all different versions of the same formula that may come in handy. All of our rate time distance problems can be solved with a table here, 6 boxes, rate, time, distance. Now, our problem says a tour boat goes 10 miles against the current in a small river in the same time that it goes 15 miles with the current. So we got against the current and with the current. Against the current, the boat goes 10 miles. So I already know the distance is 10 there. 15 miles with the current. So with the current, distance is 15. So we got that filled in already. The speed of the current is 3 miles per hour. Find the speed of the boat in still water. So we're going to let x equal the speed of our boat in still water. In other words, if there's no current. Now, when you're going with the current will push you, and so you're actually going to go faster. You're going to go your speed, the speed of your boat, plus the speed of the current, because you're going to be going faster. So x plus 3. However, if you are going against the 3 mile per hour current is going to slow it down, so we're not going to go x, we're going to go x minus 3. Anytime you have a rate time distance problem where you're going against something or with something, then we have this x plus and x minus. Okay, now time. I'm going to use this version of the formula here to fill in time. Time is distance over rate. So here it should be 10 over x minus 3. And here is 15 over x plus 3. Now I've got my chart filled in. We get our equation from this sentence right here. It says same time. In other words, this time is equal to this time. That's the equation. 10 over x minus 3 equals 15 over x plus 3. If I solve this equation for x, then I'm going to get our answer, speed of our boat. Since it does look like a proportion, I can solve this by cross-multiplying. 15 times x minus 3 is equal to 10 times x plus 3. Distribute 15x minus 45 equals 10x plus 30. Subtract 10x from both sides, add 45 to both sides, and we get 5x equals 75. Divide by 5, and we get, let's see, 15? Is that right? Let me double check that. Yeah, 15. So our answer is 15 miles per hour is the speed of our boat with no current. Let's look at another rate time distance problem very, very similar to this one. A plane travels 100 miles against the wind in the same time that it takes to travel 120 miles with the wind. The wind speed is 20 miles per hour. Find the speed of the plane in still air. Okay, so x is speed of plane. In still air. I'm going to use the same sort of chart that I used before. Rate, time, distance. And here we're going against the wind. And here is with the wind. Okay, just like the last problem, we know the distances. A plane travels 100 miles against the wind. So that distance is 100. In the same time, it travels 120 miles with the wind. So this distance is 120. Now, the wind speed is 20 miles per hour. So if I go with the wind, I'll be going x, my speed, plus the speed of the wind, 20. However, if I go against the wind, I won't be going x, I'll be going x minus the speed of the wind, x minus 20. Now remember that we got time here as distance over rate. So just like the last problem, this chart is filled in as distance 100 over rate x minus 20, and this one is 120 over x plus 20. Our chart's filled in. Notice that just like the last problem, this one says same time. In other words, the times are the same. This is equal to this. So we have 100 over x minus 20 is equal to 120 over x plus 20. And that's the equation we have to solve. So I'm going to cross multiply. 100 times x plus 20 is equal to 120 times x minus 20. Distribute. 100x plus 2000 is equal to 120x minus, is that 2400? Let's make sure. Right, 2400 minus 2400. Subtract 120x from both sides and subtract 2000 from both sides, and we end up with negative 20x equals negative 4400. And if we divide that by 20, we get a positive 220. And so the speed of our plane is 220 miles per hour. And we've solved our problem. Okay, so those are two examples of rate, time, distance problems. Let's now look at what's called a work problem. Oh, wait, I'm sorry, that's wrong. This is one more. We have one more here, rate, time, distance problem. Our work problem's right after this. Okay, let's make our chart here. Rate times time equals distance. Donna drove 300 miles from San Antonio. She usually averaged 55 miles per hour, but an accident slowed her down through Dallas to 15. Her trip took 6 hours. How many miles did she drive at the reduced speed? So let's let x equal the distance traveled at the reduced speed. So we're traveling at the regular speed and the reduced speed. Now the rate, we already know, her regular speed is 55 miles per hour. So that's 55. Her reduced speed was 15. Right there. Now it says that the trip was 300 miles, but that's not, we don't put a 300 here because she didn't drive the entire 300 miles at the regular speed. She only drew a part of it. So what I need to do is this. X is the distance she traveled at the reduced speed. That's what we made X. So that goes here. X is the distance traveled at the reduced speed. Now, if she travels that much at the reduced speed, then the rest of the distance, which is 300 minus X, the rest of the distance is what she traveled at the regular speed. Now, just like in the last two problems, time is distance over rate. So this is 300 minus X over 55, and this is X over 15. Right there. Now, in this problem, we do not set the times equal because it doesn't say anything about equal time here. It says her trip took 6 hours. So what that means is the entire trip is 6 hours. This time at the regular speed plus this time at the reduced speed, if you put all that together, that's her entire trip, and the entire trip took 6 hours. In other words, the times total to 6 hours in this problem. And so this is the equation which I want to solve. Let me fix that. Right there. That's my equation. To solve this equation, I need to get rid of the fractions by multiplying both sides by the common denominator. And the common denominator for 55 and 15, let's see here. 55 is 5 times 11. 15 is 5 times 3. So I need a 3, I need a 5, and I need an 11. So that's going to be, let's see, what is that? 55 times 3, 165. The LCD is 165. 55 and 15. So I multiply this side by 165, and multiply this side by 165. Now if I distribute this, I have 165 times 300 minus x over 55 plus 165 times x over 15, and that should equal 165 times 6, which is 990. Distribute, or actually I could reduce a little bit. 15 goes into 165 exactly 3 times. Let's fix that. 3 times, so this is now 3 times 300 minus x. 15 goes into 165 exactly 11 times. So let's say that's 11. This is 11x. Oh, that's a plus sign, isn't it? This is a plus sign. I'm sorry about that. And this equals 990. Okay, distribute the 3. 900 minus 3x plus 11x equals 990. Well, I'm running out of room here, so let me squeeze it in the end here. Combining my like terms and so forth, I'm going to end up with 8x equals 90. And so x equals 90 over 8, which is 11 and 1/4 miles. Well, that's what it reduces to anyway. And that's our answer. Okay, those are now 3 examples of rate, time, distance problems. Let's look now at a couple work problems. Stan can do the dishes in 30 minutes. Deb can do them in 20 minutes. How long will it take them to do the dishes working together? Now this is what's called a work problem. And what I'm going to do is I'm going to use basically the same formula. Rate times time is equal to distance. But we can think of the distance as work. To solve work problems, we need 9 boxes. Rate, time, distance. And we have Stan, Deb, and then both of them working together. All of the work problems are solved in this manner. Stan can do the dishes in 30 minutes. So the time there is 30. Deb can do them in 20 minutes. So that's 20. And the time, if they both work together, that's what we're looking for. So that's my variable t. So t is time working together. Now, the distances. This isn't a distance that we normally think of. It's not miles or feet or anything like that. What we want to do is get the dishes done, one set of dishes. So all these are going to be ones. We always do this with our work problems. We put ones in place of the distances. Now, rate is distance over time. So here, rate is 1/30, distance over time. In other words, Stan's rate of work is 1/30th of the dishes per minute. Deb's rate of work is 1/20th of the dishes per minute, and this is 1/t. Our equation comes from this column. Stan's rate of work plus Deb's rate of work should be equal to the combined rate of work, 1 over T. That's the equation we need to solve. The LCD to get rid of the fractions would be, let's see, that would be 60T. At least the least common denominator, 60T, so I'm going to multiply both sides by that. 60T, 60T. Distribute. That's going to give me 2T plus 60T times 1 over 20 is 3T. And on the right side here, the T's cancel away, leaves me at 60. 5T equals 60, so T is 12. If they work together, it will take 12 minutes. That's our work problem. So let's look at one more just like this one. Very similar anyway. Moving on. 9 boxes. Rate, time, distance. Okay, you and your friend together can clean the house in 15 minutes. If you take 35 minutes alone to clean the house, how long does your friend take to clean the house alone? So you have you, your friend, and then both working together. Okay, now it says you and your friend together. You and your friend together can clean the house in 15 minutes. So here the 15 is in that box, the time it takes both of you together. You alone take 35 minutes. So that's 35 there. How long does your friend take to clean the house alone? Our T is right there, the time it takes your friend alone to clean the house. Just like in the last problem, all the distance are 1 clean house. Just like that. The rates are distance over time, distance divided by time, so this is 1 over 35, this is 1 over T, and this is 1 over 15. Just like in the last problem, this gives us our equation. Your rate of work plus your friend's rate of work should be equal to the combined rate of work, 1 over 15. That's the equation I have to solve. To do that, I need the common denominator. And the LCD here for 35 and 15 and T would be, I know there's a T in it. For 35 and 15, let's see what we have here. 15 is 3 times 5. 35 is 5 times 7. So it's going to be 3 times 5 times 7, which is 105. Okay, the common denominator is 105T. I'm going to multiply both sides by that. Let's distribute. 105T times 35 is 3T actually. And here is the 105, the T's cancel away. And on this side we are left with 7T. 105 will equal 4T. Divide by 4. And we get 26 and 1/4. And so our answer is 26 and 1/4 minutes. The time it takes your friend alone to clean the house. And I believe that ends our lesson on applications of rational expressions.